This lesson will be on the Doppler effect. The Doppler effect is the apparent frequency shift that results from the relative motion between the source of a sound or a wave and the observer. A will depict a higher frequency and B will depict a lower frequency. The source of the sound doesn't change frequency. So in other words, a car horn will sound the same to the driver, no matter if the driver is moving or not moving. But the source of sound is catching up with its own waves at A, so therefore A hears a higher frequency. And it's running away from its own waves at B. Now let's think of this: if the car wasn't moving at all, it would make concentric rings around it, rings of sound. Actually, it would be spheres, but since it's two-dimensional, we'll think of it as rings. And they would travel out equally in all directions. And in that case, if it wasn't moving, the wavelength between each of the waves would be the same. But since it's moving in this case to the left, as it emits a sound, it moves to the left and it catches up with them. So person A sees these waves coming to him at a higher frequency than person B, where they tend to be running away from it. Since motion is relative, it really doesn't matter if the source is moving or the observer. So for example, if we had a stationary source and it was making concentric rings as I talked about before, and now in this case the observer moves towards the source, the observer will hear a higher frequency. And as the person moves away, they'll hear a lower frequency. Now I have to caution you at this. There's a lot of people get the idea of change in frequency mixed up with loudness. Obviously, if you walk towards the source of a sound, it's going to get louder. That's not the Doppler effect. It's basically, well, common sense. As you walk away from it, it's going to get softer. That's not the Doppler effect. It's when it changes frequency. Alright, the Doppler effect is just not for sound waves. For example, here's an absorption spectrum of an element. Let's imagine we're looking at a distant star, and the star is not moving relative to us. We would have this absorption spectrum. But now imagine the star is moving towards us. So we see a higher frequency because of the Doppler effect, and the whole spectrum is shifted to the left. And the more it's shifted to the left, to the blue, the quicker it's approaching us, so we can tell the relative speed between us and that star. If it's shifted to the right here towards the reds, obviously the star is moving away from us. So that would be a red shift. So they can look at different stars and galaxies and tell if they're moving towards us or away from us using the Doppler effect. So that was just a brief introduction into the Doppler effect.